We have not been concluded. You're just trying to mess with my mind. You Photoshop something to try and trip us.
You managed to go through it?
Yeah, I know. Doesn't show up on mine. How are you? It's the same. I don't know, on the HTTP version of our site.
So clearly somebody's trying to send us a message, right?
We've been hacked. Somebody closed our working group.
But only a portion of the working group works.
Or if you connect with token binding, we're still active. But the non-HTTP version seems to have been concluded.
Okay, let's get started.
I'll check that. I turned it on for you, so now you can speak. I wonder where that one
Hey, can you put the note well up or something?
All right.
The pen is broken.
We know it's Friday.
Yeah. So rumors of the working group having been concluded are exaggerated. Okay, so you are in the token binding work group. If you think you should be someplace else, then you have a life and probably don't belong here. This is the note. Well, wait, that was the note. Well, you will have noted it well. We have an agenda. Bashing the agenda, we've got a couple of presentations from our two authors, and then open mic questions.
Pretty simple.
And of course, the area directors will introduce some controversy. Oh, you're just changing. Okay. The area directors will figure out why IETF tools has gone berserk. Okay.
I'm just going to find the right set
No,
of slides for our next
we're not
step.
starting. We're not starting with dirt.
We're starting with this. Negotiations?
Yeah. You can get up and stand in the box. He's gonna get it real soon now.
There we are.
Okay. So I'm Andrei Popov. I'm with Microsoft, and I will talk about two different internet drafts today. I'll start with the new one that I wrote recently, the token binding negotiation draft. Next slide, please. So in order to use the token binding protocol, the client and server need to negotiate the version of the token binding protocol, and they need to negotiate the parameters of the token binding key that are acceptable to both client and server. The original version of the token binding protocol internet draft used LPN IDs for this negotiation. In Dallas, this working group decided that LPN IDs are not great for this purpose. There is Cartesian explosion and other issues with them. So the decision was to define a new TLS extension for token binding negotiation. And this is, this internet draft that I'm talking about is, my first take on that. So next slide. Okay, so the client that desires to use token binding includes the token binding extension in the client hello message. The token binding extension data structure is really pretty simple. It contains the version of the token binding protocol, which in the best traditions of TLS has a major and minor bytes. And it contains a list of key parameters. Each set of key parameters, such as RSA 248, PKCS 1.5, SHA-256, is one code point, so one byte. So the list of parameters is basically a variable length sequence of bytes. The token binding version indicates the supported version, the version supported by the client in this case of the token binding protocol. I'm really thinking about using this for prototypes of the token binding protocol, where that version could express the version number of the draft that a particular implementation supports. I think that will be useful to prevent any kind of collisions between different versions of the drafts. Then the key parameters list contains the list of identifiers of the token binding key parameters supported by the client in the descending order of preference, so the most desirable one first. Next slide, please. The server hello extension, basically the server uses the token binding TLS extension to indicate support for the token binding protocol version offered by the client and to select key parameters. So in this first version of this internet draft, I'm trying to keep things as simple as possible. So I chose to say that the client offers a version and the server either accepts that or doesn't send the token binding extension. We will discuss this today, and if somebody is interested in a more elaborate negotiation of token binding protocol versions, we can do something like that. But for now, it's very simple. So the server agrees to the client version, then the server includes the token binding TLS extension. So the server that supports token binding and receives the client hello message containing the token binding extension will include a response. It will include a token binding extension in the server hello if all of the following conditions are satisfied. The server supports the protocol version offered by the client. The server finds an acceptable token binding key parameters, a set of key parameters. Basically, one of the bytes matches what the server can do. This server is also negotiating extended master secret TLS extension because token binding depends on the TLS unique, and TLS unique is not really unique unless you have extended master secret. The structure of the server-side token binding extension is the same as the client's, but there is only one token binding key parameters identifier that the server sends. And again, we can discuss maybe it may be useful to negotiate multiple. We'll get to that next. Next slide, please. So this slide really talks to the general rules for negotiating the token binding protocol version key parameters. So the server can only select a token binding key parameter identifier that the client has offered. The server should select the server's most highly preferred key parameters, which the client also supports. So the assumption is the server has a list, also a prioritized list of key parameters that the server supports. And in the event that the server supports none of the key parameters that the client advertises, then the server must not include the token binding extension in the server hello. And then basically the client, when the client receives the token binding extension from the server, the client verifies all of the above. So the client makes sure that, first of all, the client did advertise support for token binding, so the server cannot just volunteer to do that. The client makes sure the token binding version that came back in the server hello matches the client's token binding version. The client verifies that the selected key parameters have been actually advertised by this client. and that extended master secret has been negotiated. Next slide, please. So there is an open issue with this that has been raised, I think, on the mailing list. In a federation scenario where we have a client connecting to an IDP and a client connecting to an RP, which are two different servers, it's possible that the client will negotiate, for example, ECDSA with the IDP and RSA key with an RP. Then if that RP redirects the client to this IDP, then the IDP will receive a referred binding with an RSA key in it, possibly. At least it's conceivable. One could say that this is a misconfiguration between the IDP and RP, or we could say this is acceptable. This is something we need to decide on. So if in this case, if this were to happen and the IDP cannot handle actually an RSA key, then it will issue an unbound token in this case. That's how the documents currently, that's what the documents currently say. So the question is, should we allow the server to maybe send multiple algorithms so the client knows a list of algorithms that the server supports, in which case the client can not even try to send this referred token binding to the server to avoid this kind of awkward situation. It's possible, it complicates things a little bit, but it could be done.
Yeah, so Martin Thompson, I have other questions, but if we consider that this is similar to the signature algorithm extension, then this is largely declarative when it comes down to it. And the client can say, I can produce the following bindings, produces a list, and the server says, I can consume the following bindings. And then the client can make a determination at that point as to whether it wants to continue with this process. Now, issuing unbound tokens when both peers actually support the protocol seems like a pretty poor failure mode. I'm not entirely happy with that outcome, but I'd be happy to go through the reasons. If someone has a good reason for that, we can go through and describe what the security considerations are for that. But I would say my preference would be don't do that, one, and failing that, simply say, in that situation, fail. So when I say don't do that, I mean don't get into a situation where you're a relying party for an IDP that can't produce and consume or consume the right sorts of token bindings.
So you're basically saying it's a misconfiguration of this happens.
It's a misconfiguration of the two of them. I mean, there's an alternative answer to this, which is to say that you only have one signature scheme and do away with it that way. But I don't think we're quite there yet, particularly when we have the IAB saying that you need crypto agility. So
yeah,
I mean, you could have an MTI,
right,
which would cover that.
Yes, but your vote is basically for the client and server to negotiate multiple algorithms, and any one of those can be used, basically.
Yeah, I mean, it's an advertisement.
Mm-hmm. Okay.
So John Bradley Ping as an individual, I don't think it's actually that as much of an issue as you're imagining, because there are actually 3 parties and 3 keys involved. There's the trust relationship between the client and the IDP, the client and the relying party, and between the relying party and the IDP. If there's no trust relationship between the relying party and the IDP, you've got a problem. You probably shouldn't be doing this in the first place, at least in the federated scenario. So the fact that the IDP gets a key that it can't directly support actually isn't relevant. All it needs to do is put it in a token that it's signing with whatever algorithm it's negotiated with the relying party, which doesn't have to be any of the ones that have been negotiated on via token binding. It could be some completely different algorithm and completely different token format. All it has to happen is that those 2 parties have to have agreed on enough that the relying party can take that token, find the public key in it, and then verify the binding. So I don't know that you actually have to agree on the token binding across the 2 legs.
And that's exactly the reason why, in the current version of the draft, I only negotiate one algorithm. So that's the counter argument, basically.
Yeah, so Martin Thompson, I actually found that fairly convincing. If you think in this situation that the IDP will accept any key advertised by the client as it pertains to the relying party, and simply insist that once that binding has been made, the relying party enforce that binding, then I think we're fine. This is
John,
kind of
again,
complicated in
I
my-
expect that a sensible identity provider is likely to do that.
Right.
Yes.
So the identity provider can say, well, you've asked for a binding to this particular key. I will provide that binding. And if it turns out that you cannot produce evidence that you own the private key associated with that, well, then too bad for you.
Fail.
Yeah. Yeah. I'm happy with that, actually. That's a pretty good answer. And that means then that you can say, you can have the server simply declare, I'm happy with this. There's another design here that suggests itself in that case, which is that the client advertises its willingness to do token binding. An empty extension, if it came down to that, maybe a version parameter. I'm not have qualms on that, maybe, but then the server says, here's your options for producing those tokens, and then it's exactly like signature algorithms. I would then actually ask the question why you aren't using signature algorithms, and if the answer is to save bytes, I'd be a little bit sad. But
I don't exactly like this design for the reason that, so in the current design that we have, the client advertises its capabilities, which is a common design for a lot of TLS extensions, and the server picks the options out of what the client offers. And once the server has responded, there is an expectation that token binding will happen. So like both sides can then enforce that token binding will happen. Whereas if the server just, sends something and the client decides and the server doesn't know should the token binding be
it won't actually know
not.
whether the client actually supports the options that it's presented.
Right. So I do like the
you want a negotiation here.
Yeah, I want a negotiation, a determinism at the end of it. So I know that it has to happen. If I went, if I send something to the server responded, then it's happening. I kind of like that property of it.
Fair enough.
Dirk Balthans from Google. John, were you saying that the IDP doesn't have to verify the referred binding? Just bind the token, but not really
By
not
design, I believe it can't verify the referred binding.
So if it can't verify that the client is actually controlling the key, it shouldn't make a statement.
It has to. It's simply a trust of the user agent that the user agent, which controls the key that is being verified, is saying that it also controls the other key. Unless I've missed something completely, it's just a belief.
Actually, Dirk hasn't attacked it. If you did that, if you did not verify the referred binding, if the IDP did not verify the referred binding, then Dirk has an attack on that. So we actually do that verification.
Okay, maybe we should leave that to Dirk's presentation. I don't know.
I have an attack for that.
Yeah.
It just seems
You're cleverer than you knew.
It just seems weird that the IDP makes a statement that says the client controls this key when it didn't actually check that.
Right.
Okay.
That would be
Well, it's checking via the fact that the token bound channel, the other end of the token bound channel is asserting that it controls that key. The user agent is saying it controls two keys.
Sure, but we want to make sure that the client that is talking to the RP is the same client that the IDP saw, right? If the check checks out when the RP is doing the check, that doesn't mean that you're actually talking the same thing that the IDP saw.
Exactly, yes. So the client needs to prove possession of both the RP key and the IDP key to the IDP. Otherwise we have a vulnerability there.
I would like to understand that vulnerability in a little more detail.
So
because it's not quite clear in my head what the threat model is here. The client that we're talking about here could offer a random If you don't verify this key that the relying party is expecting to see, the client can offer a public key for a private key that someone else controls. So we could collaborate. I could just steal your public key, for instance, and then gain an assertion. But you're the only one there that can benefit from that. Is that not right? I mean, we are talking about. I mean, you're the only one who can actually use this key, this binding that the IDP is produced now. Now the question is whether or not you want to be able to impersonate yourself as me. But if we're collaborating to that extent, then we can collaborate.
I'm trying to remember Dirk's motivation for this, but I think the idea was that we want to make sure that the client possesses both keys, that the client is not signing, that the client is not sending bindings for keys that some other machine possesses.
So is that part of your next presentation? Should we perhaps get through the negotiation part?
Yeah, let's talk about the negotiation thing, but I'd like to come back to this because I think it's
that's
critical.
the next presentation, I think.
Yep. Okay, so on this question, did we agree that we will negotiate only one key parameter ID, basically? And the
Unfortunately, the more that I think about it, the more that I think we need to answer the other question, which is, do you need to verify the key that the RP is going to be relying on? Because if you need to verify both of them, then
you do.
Then you might want to advertise multiple.
But we decided, but based on the question, but based on the assumption that the IDP and the RP will always negotiate between themselves. So there is a relationship between the IDP and the RP, and they will only negotiate.
If that's your position, then I think this is reasonable, actually. And I simply stated it as a restriction on the IDP RP thing, and that creates the right sort of incentives for the IDPs and RPs to actually use a good algorithm as opposed to one that's really slow and crappy.
Yep. Okay. So next slide, please. I don't know if there's. Yeah. So that's the end of this one. The next slide deck I wanted to talk about is the token binding protocol internet draft. So once I changed the negotiation mechanism, now I updated the token binding protocol draft to agree with the other one. So next slide, please. So since IETF 92, I made a couple of changes here. So I replaced LPN-based negotiation with TLS extension-based negotiation. I added a security consideration subsection at the end discussing token binding key sharing between applications at a very high level, and some minor edits and such. Next slide, please. So there is an open issue that was raised on the token binding protocol draft. Basically, the negotiation draft is using those 1 byte key parameter IDs, whereas the protocol draft uses a TLS style kind of structures to convey hash and signature algorithms. And there was a question asked on the mailing list, I believe, whether we should just merge those and use one way of expressing key parameters. Because if you have both, then you need to, in your code, you need to convert from one to the other to ensure that what you negotiated is actually being used. So I'm kind of actually personally leaning towards just using 1 byte IDs in both drafts and kind of harmonizing them this way. I don't know if anybody has any other opinion on this.
Chinese menu versus sweets. So we have that.
Yeah. It seems reasonable to use the same in both places. And the 1 byte IDs seem to be more simple. Just from that perspective, I think.
So Martin Thompson, the primary advantage here that you get from reusing signature and hash algorithm is that you don't have to go through the process of defining new code points when TLS adds a new signature algorithm, and who knows, maybe that might happen any day now.
But if the negotiation draft uses 1 byte IDs, we still need to define those. There is already a registry for those.
Right, so
we could as well reuse that.
Is there a registry for 1 byte IDs for signature algorithms?
Well, we're creating it with the draft.
My suggestion would be that you don't want to maintain another way of identifying signature and hash algorithms. And you can then take advantage of developments in hash algorithms, which, having been at the CFRG earlier this week, seems imminent.
So you are saying let's use the same TLS style structures in the negotiation draft as well. So let's make
Right.
the extension a little bit more complex.
It would make the extension larger,
Larger a little bit. Yeah.
not functionally more complex. I mean, you would actually have fewer options because we don't have a way to distinguish between PKCS15 and PSS, which is something that we might want to talk about.
Yes, and the other issue is that the 1-byte IDs also include the length of the key, for example, which signature and hash extension doesn't.
I'm not particularly cut up about that. We have a... So... Yeah, P256 is 256, no question there. I'm not actually all that concerned about the RSA thing because we can patch that with text. We can simply say that RSA must be 2048 or some range of values that we quite like. If you subscribe to the Gutmann theory on RSA key lengths, then
right,
it might be some other number.
Right, but if your keys are hardware bound, then you want to know what your hardware actually supports, and it might not be, the entire range of RSA key lengths.
Are you suggesting that verification would be hardware bound?
Because
it's really the consumer that's the problem.
No. The key itself, right? So if the client is using hardware-bound keys, then the client can only negotiate certain lengths of keys, right, with the server that the client's hardware actually supports. So for that reason, that length is right now negotiated.
Is that really so much of a problem if you advertised RSA and your hardware was only capable of producing 1024, then you simply aren't able to use this protocol. And if you are able to produce 2047, then that would be up to the server to decide whether it thought that your RSA key was acceptable or not. And of course, we could specify that 2047 was completely inadequate. It's whatever that difference is. I forget what it is, but it's not much of a difference, is it?
Well, it seems that negotiating the key length is a useful thing to do because the client has only a range of key lengths that the client can support, and the server has its own security requirements.
Well, presumably, the client is only willing to produce, for argument's sake, one length. Maybe they have some way of producing other lengths that might be less good, but we're only offering one option here. It seems perfectly reasonable for us to require that there only be one option.
For now, that's the case.
Now.
Yes, for now,
I mean,
that's the case.
If we bake that in, then when we want to do, 31, 3092 or whatever it happens to be, then we have to come back here and talk about it again. And I don't really want to do that.
Okay, so you don't like the IN registration of a new.
I don't think it carries much value since you will be carrying the length of the key when you share the public key.
Yes, but I don't want to send the key that the server will reject and break the connection. I would rather drop token binding than break the connection. I guess that's the...
Under what circumstances will the server reject a key based on the length is the question.
So if the client, say, sends a shorter RSA key than the server is comfortable using, I would rather the connection continued without token binding than we just immediately, broke the TLS connection.
So this is only an issue for RSA keys, correct? Because all of the curves were specifying the actual curve itself.
For the curves, yes. If we did, for example, Diffie-Hellman, no, I don't see how that would be.
You mean like a DSA key?
A DSA key, yeah.
Is anyone seriously proposing doing a DSA key here?
Anyone?
Can we get a hum? I mean, yeah. So I mean, what if we say, look, like RSA is RSA 2048 for the spec, and if you want something stronger, then you need to define something stronger as a new. But if you say RSA, we're saying 2048. The spec just says if you've mentioned the RSA, any RSA algorithm is 2048. That's a minimum. And then
the problem is we also need to negotiate the maximum. You see what I mean?
Okay, so we say RSA is RSA 2048.
Mhm.
But that's like if you've like if you want something stronger, then put something else in. But we've got RSA 2048-bit
Mhm.
RSA, and anything that specifies RSA is that.
That's
I mean, that's
fine.
it's brittle, but people are moving away from RSA. So I
Yes,
mean,
the
we don't
problem
have
is,
any other stronger options for the elliptic curve either.
right, but the hardware is moving very slowly, so I'm a little bit not sure that it's a good idea to drop the key length negotiation. That kind of concerns me, but point taken. So far, does anybody else, prefer the other option? Everybody thinks that it's a good idea to use in both the negotiation draft and the protocol draft to use the TLS style signature and hash algorithm structures.
The question is not just using those TLS style structures, but maybe actually reusing a registry.
And reusing the registry, yes.
So that we don't have to
consequence.
maintain any extra registries.
Yes.
So I do have to point out an error on the slides here.
Mhm.
The values in TLS are RSA and ECDSA. You do not choose the curve. Now that may change your assessment. We have
Yep.
RSA, DSA, and
Yes.
ECDSA.
Yes.
Those are the three values well.
Yes.
And
So I already
anonymous.
had to.
Anonymous is awesome.
Yeah.
Yes.
So I already had to define new code points, basically, regardless.
Well, I mean, like the DKG suggested for RSA, you can say if it's ECDSA, guess what it is.
That would be even worse. That would be because we're definitely going to progress to different curves, right?
Well, depending on whether you consider the output of the CFRG to be interesting, it's likely to be a completely different scheme.
Yes.
Rather than ECDSA. So, but in any case, we have that problem.
Mm-hmm. So I think since we need new IDs anyway, I would recommend still 1-byte IDs.
Yeah, I think
it seems more simple.
Reluctantly, yes, would be my conclusion on that one.
One question would be is if in TLS 1.3, if it would make sense to have more specific signature specification.
So one example of that might be that RSA could mean RSA PKCS 1.5, and you might have to define a new code point for PSS.
Yes.
Yeah.
I think it's not necessary for us to tie the two together, though. Some degree of independence between TLS 1.3 and this spec is probably good as well.
Well, I mean, but we're looking at signature algorithms, and so it's not really tying the two specs together. The two specs are referencing the same registry, and I mean you're already tied to TLS in some way, right? So I don't want to artificially generate something completely new when we don't have to. But I mean, it's a good point. Right now, I think it doesn't make sense, but I think we should look at TLS 1.3 and see if, because there's the algorithm negotiation there or the signature negotiation, it's a little bit rough, right? I don't think it's the way we necessarily really want it.
Yes.
So we ought to take a look at that.
Okay.
But
so we'll table this question for now?
Yeah, I think so.
Okay. Okay. And is there anything else? Let's see. So the token binding extensions. I think Martin Thompson raised this issue. Basically, token binding protocol as defined now allows extensions in the token binding message. The extensions are basically, type and a blob of variable length, but the length is defined up front. So if you don't recognize the type, you just skip that extension and go on and look at the next one. So at this point in our draft, no extensions are defined. Having said that, I have a lot of ideas for extensions to this. One of the ideas is, and a very likely thing that we will pursue, is attestation where the a peer can actually prove that the key is stored in hardware. It's hardware bound. So there are some uses for these extensions. Right now, we don't define any. The question is, should we keep extensions and should we get rid of extensibility in the token binding protocol? So opinions are very welcome.
In TLS, you can use a TLS extension. You can define a new token binding extension if it came down to that.
These extensions are not per TLS session. They're in each token binding message. You can have,
itself.
you're proving that this key, for example, if it's at a station, you're proving that this key that you're sending in this token binding message, that it's this specific key is hardware bound.
You're not signing it either by my reading of that. So that would be interesting. I'll have to think about it. I'm still uncomfortable with the idea that we have extensions and
none of them are defined.
Use cases, and I've seen what happens when you do that. You find that it's completely inadequate. Or answer the question for me: does the signature cover the extensions? And should it cover the extensions?
Yes, because extensions are part of the token binding message. Yes.
So
they will be covered.
As it appears, it doesn't look like that's the case. And those are the sorts of errors that you're likely to encounter when you don't actually have a use for them and haven't actually defined anything yet. So
we will correct that.
Yeah.
That part will correct, yes. So do we agree to keep extensions for now and just make sure that they're signed? Does anybody have any other opinions on this?
I mean, I don't have a real strong opinion, but simpler would be better, right? So if we don't have a real specific need for it, but I mean, it sounds like you do. So
I have intentions for it, yes, definitely.
So everyone, there's this rule, isn't there? It's a rule of 3.
Mm-hmm.
If you're looking for something that's general and flexible,
mm-hmm.
you first identify 3 things that you want to do with that general flexible
mm-hmm.
thing, and if you do it with 2, that's unwise, and if you do it with 1, you're foolish, and we have 0. That's what I'm worried about.
We can always, I mean, we could get rid of extensions now and then define a new version of token binding when we need them. That's another possibility.
That's what I'm suggesting.
Tom Stady, Mozilla. I'm a bit concerned about when you say you want to likely future uses, proven used some sort of hardware thing, because this whole extension is basically, previously assuming you're trusting the client, right? And now suddenly you have this thing where you don't trust the client to use the hardware module, and you want, you're now trying to do this whole verify the client thing, and you're not actually trusting the software in the client, which is a lot different. And I'm not sure if that fits in with what the rest is supposed to be doing.
So the idea is that hardware-bound keys are inherently more reliable and less likely to be extracted from the machine. And for that reason, some servers may want to enforce, may want to ensure that this key is hardware-bound, for example. So I can see in some highly locked-down systems, think about banking or something like that, they would want to ensure that the client actually stores the key in the hardware module. That's the scenario.
Joe Salloway. I think we may be getting down the path of this attestation thing,
mm-hmm.
But it may be that you could also indicate that is a different signature algorithm as well and tie it to the signature.
Yes. There are multiple uses we can think of for this, but. So how do we decide on this one? Extensions or no extensions?
So it does sound like there is. I'm not hearing people protest against the notion of having extensions signed if we're going to have them, right?
Yep.
It feels like a no-brainer. But the question is whether people feel comfortable enough adding extensions at this point. If we could do a hum on that, I mean, that'd be fine, right? And so in that case, we should do like a 3-part, yes, no, I need more information, right? So if anybody who feels that, yes, I know enough to say, and extensions are fine and they should be signed, should hum and add it now, right? We should add extensions in the draft right now. They should be signed, hum now. All right. People who feel they need that extensions are definitely a bad idea. They shouldn't be added, or they at least shouldn't be added to the draft right now. Hum now. All right. People who need more information need more information to decide. I don't know what's going on. How now? I said this is a tricky one because nobody wants to admit they don't have a clue, right? So, yeah. Well, I mean, there's at least very weak support for doing extensions now. So I think we need to revisit this.
The weak support was for delaying. Was the second hum.
Yeah, I thought the support for, yeah.
Well, it's only the author that has the support for the extension now.
Yeah. So at least we should, my understanding is, correct me if I'm wrong.
Pretty weak.
It's pretty weak, right? So,
The delaying option sounded like it had more backing.
Mm-hmm. Okay, so we're cutting them from now. For now, we're cutting extensions.
Or you need to
make a better case, right?
You need to make a better case and really lobby for why adding them later would be a bad idea. But for the moment, I think you need to plan on adding them later and make the argument if you really want them now.
Well, we can always gather again and define a new version of the protocol with, new features. So, okay.
Quick question, Dirk Valkens from Google. How would the code that I would have to write today be different in these two different options? If we have the extension stuff spelled out here, but no extensions exist, versus we don't spell it out.
So if no extensions exist, then the extensions will just specify 0 length, and that's it. We just put 0 in that 0 length array, and that's it.
So, but in the code that I would write today, I would look for the 0 length.
In the code that you write today, you would look at the length of it and make sure that the buffer that you receive is valid. So you would look at that length and make sure that that length fits in the buffer, and that's all you need to do. Because your code doesn't handle any extensions.
So I think once you define an extension mechanism, then you need to define what to do when you encounter an extension that you don't understand.
Yes, and it's already defined in the draft as saying you don't understand, you skip it. Go to the next one.
So there's then no way to add an extension that's critically important that the other side must understand in order to use it.
Right. Extensions are optional right now, as they're defined.
But we don't have, we don't know what these extensions are going to be. We don't know whether you might want an extension that would be critical, that you wouldn't want the peer to accept if it wasn't there. So we're making decisions based on very little knowledge.
As any other extension mechanism, ETLS as well.
So what? But since you have some idea about what, I think I can guess, right? What you want to use this for. So why don't you just write that up?
I'm not ready to.
You don't have to put it in the draft. Just let's start a thread on the mailing list and see if we can actually have some more information about it.
That I can do. I can put it on the mailing list, but I cannot really draft it right now because I'm not ready to spend that time. It's a very non-trivial thing to do.
Don't draft it. Talk about it.
Right.
Yeah. And ultimately, if we want to do the sort of thing you're talking about, we can put it under signature and include it on the wire without actually an extension, and it'll be more efficient as a result. And I think, and you could use it in TLS. Yeah, if this was a signature algorithm, if this was something bound to a signature algorithm, yeah, you could do it. I'm not sure that I like that idea, Joe, but
I'm guessing there is a difference between things that are bound to the TLS session and things that are bound to the token binding, right? And that's the point here, right?
Correct. But I signal that this is a hardware-bound key. If you have state, is interesting. It's not particularly interesting if you don't, but if you have some sort of state, it is interesting. So I would suggest we have this now, and at some later date we will have something else that maybe looks different and may include some of the things that you want to turn into extensions. And maybe that's awkward from a protocol revisioning perspective, but I'm sure we can work that out, because you do actually have a version field, funnily enough.
Yes, I do have a version field, so we can add those things in the future for sure, yes.
Which, by the way, I don't like, but we'll get into that later.
Okay. All right. And I guess we can look at the next slide. I think this was the last issue. Yeah, so that was it. Any other questions so far before we get to the HTTPS token binding?
So one thing on these documents, in the last meeting, we decided to split the document, so we now have another, so we had one that was adopted by the working group and a new document that you've just created
Yes.
as a result of the split, which has not yet been adopted by the working group, though the
Which is
working
something I
group
would like to ask for.
previously, which the working group previously indicated should be
Right.
part of the working group. So do we have consensus or rough consensus here to do what we had initially anticipated, which is bring the new document in as a working group document so that we can beat them up officially? Anyone opposed to bringing it in? Yeah,
Negotiation
the-
draft, yes.
the results of the split. Okay, so we'll bring it in and list it in the working group pages.
So
Great.
I suggest, Andre, that you do the next revision
Mhm.
with minor cleanups based on this and rename it, right?
Right.
In the obvious way.
And publish
then-
it, yes,
so
I'll do
we'll
that.
just approve that.
Within 2 weeks.
Perfect, thank you.
Before you wind up, there were questions that came up in the first part about how
do we
you
need to-
do the attestation of 2 keys.
Why do we need to prove possession of
Well,
both keys? Yes, that was the question.
I suspect the question was more, how are we doing it, as opposed to whether or not it's a good idea.
Oh, so basically both keys are verified the same way, where the client basically you do signature verification twice. You do signature verification for the provided binding, and you do signature verification for the preferred binding, and that way you ensure that the client has possession of both keys, so you can actually bind your tokens that are intended for the RP to the second key, to the referred key.
So there are two.
Yes, you receive 2 separate token bindings. You receive the provided token binding, you receive the referred one, and you verify both. And you bind different types of tokens
And
to the
they're
resulting
both
key.
signed by the same, or they're signed by 2 different keys?
They're signed by 2 different keys, yes. The client uses different keys for the IDP and for the RP because we don't want to link, an observer to link the client to both servers.
Except that both keys are asserted to the same server. So that does kind of link them by definition.
So the
Receiving
linkability,
both keys signed.
so the linkability properties here are that the client talks to the IDP and provides keys that it would use ordinarily with the IDP, which are unique to that IDP, and keys that are unique to the RP. So the IDP gets to see both of those things. But the assertion here is that the RP is providing information to the IDP anyway, and would be able to provide that information if it so chose to do so. The question that I have is whether having a signature over that information is actually making that information much more tightly bound to the client and much more certain is an issue.
So is there a signature over
the signature
over both of them, or is it just inferred because it's coming in on the same TLS connection? Well, there's a signature over both of the TLS. Well,
no. So the TLS unique is signed twice.
Right.
Once with the key that you would ordinarily see.
Yes.
And once with a key from some other server.
Right.
Yes.
But are they both oversigned by the same key that's on the TLS session, or are they're associated by being on the same TLS connection?
They're in the same request.
They're in the same request, yeah. They're basically 2 different signatures that you verify, that you validate.
So they happen to be in the same message, but they're not conventionally signed by the same key.
They're not both signed.
So you couldn't take it out of that context
and send them separately.
These are signatures over the TLS unique. It's not really all that interesting outside of that context. I hope we have personalization strings in here, by the way.
We do.
Yeah.
Okay. Anything else before bring up Dirk? Any questions from the chat room that we're ignoring? Didn't see any. Yeah. No, just people coming and going.
Hi, I'm Dirk. Next slide. I thought I'm going to So this is what I want to talk about. Thought I'm going to start off by recapping. Is there anyone here that wasn't in Dallas? Okay, so there's a couple of people. Recapping what this, I guess now third draft is covering. Go over the changes that happened between Dallas and now, and then talk about two open issues that came up on the mailing list. Yeah, I'll explain them when we get there. Next. So what Andre described so far is a data structure that says here's how you represent a signature over the TLS unique given a key. What this particular draft here explains is how you put that signature, how do you use this in HTTPS? And the answer is you put it in a header. So when the client sends a request, HTTP request to the server, this data structure that you just saw in Andre's presentation is base64 encoded and put in a header. Okay, next. And Andre already mentioned this. The point of this thing is that you prove to the server that you control a certain key pair, and you use different keys for different servers for privacy reasons, unlinkability. Next. And this whole thing is called token binding because we think the server will bind tokens as a result of this. So none of what we said so far has anything to do with bindings and tokens, right? But we call this token binding because we think what the server will do next is that they will use this information that they learn that the client controls a certain key pair and bind their tokens to that key pair, their cookies, their OAuth tokens, and so forth. So that's why this whole thing is called token binding. So here's an example. If the cookie that the server normally sets is like some data structure that has the user ID in it and whatnot, presumably the server would add another piece of information in here that is the public key of that key pair that it learned the client controls. Next. All right, so that's basically the idea. Changes since last time. Next. So there's this thing we're going to talk about in a moment. I renamed it the header from token binding to SEC-token-binding. Presumably that causes, that makes it so that JavaScript can't set the header when it launches XHRs. Only the actual user agent will be able to produce this header. There was some clarification in the text. The word token binding ID in Andre's draft refers to a data structure that contains a public key and then this little tag that says whether it's a provided token binding, meaning this is the public key that I normally use to talk to you, the server, or whether it's a referred token binding, meaning this is a public key that I normally use to talk to someone else, but I'm also proving to you that I possess the corresponding private key. So it's the public key plus the tag. And when you bind tokens, you really don't want to bind them to that thing, to that pair, key and tag. You just want to bind them to the key. So there was some text in there that made that. So Anna taught me how to spell true. Anyway, if you see the div, you can see that. And then the largest change really was that I removed any mention of JavaScript APIs from the draft. And we'll get to that in a little bit, why they were there in the first place and so forth. But basically the idea is that we need support for token binding and at the JavaScript layer, some API, but we're not going to do that here. Somebody else is going to look at that. And so I removed it from the draft. Okay. Next. So the two sort of issues that came up on the mailing list. One was, do we really need this extra prefix to the header? In other words, do we really need to prevent JavaScript from setting the header ever? So I want to talk about that a little bit next. And I want to talk about it in terms of a threat model. What is that we're trying to achieve and what is that we're trying to prevent from happening? So what we really what's really happening is that when the server receives one of these signed statements and verifies that yes, this public key that is mentioned in the token binding ID does in fact, when I use that to verify the signature of the TLS unique, and the signature verifies, what the server would like to conclude from that is that the client that sits at the other end of that TLS connection is in control of the corresponding private key, and no one else is in control of that corresponding private key. Why would we like that implication to be true? Because when we bind tokens to these public keys, that's really just a proxy for saying, I want that client to be able to use that token and nobody else. And the only way I can say that, I want to bind the token to that thing, to that client, is by binding it to the public key. And then hoping that nobody else but that client controls the corresponding private key. So the token binding, really the intention is that we're binding the token to a certain client, and the way we do it in practice is we're binding it to a public key. Next. So how could that implication that I have back there on the upper right, how could that possibly be violated? And there's sort of two attacks, right, that are sort of duals of each other. One is that the attacker uses the victim's key. So there's a client that wants to talk to a server, and then there's an attacker that wants to sort of impersonate that client, right? So if I learn somehow that client's private key and I can use it, and I talk to the server, then that implication up there is violated, right? When the server sees the signature, it can no longer, in fact, truly infer that it's really that client that is controlling the private key, because it was really the attacker. And the dual of that is if I can trick the victim into using my private key, right? Either I use the victim's private key or the victim uses my private key. That also violates that intent up there. And what kind of attacks might be possible if I can trick the victim into using my private key? Well, let's say the server actually uses the private key as some sort of credential to let the client log into an account or something. Presumably, I also still have that credential. I somehow gave the victim the private key. I somehow tricked the victim into using my private key. Things like surveillance might be possible. I can log into the same account that I know the victim gets logged into, and I find out what their search history is or something. So we don't want either of those two things to happen. Next. So how do we make sure that these things don't happen? Well, the first one is pretty easy. That's why we use public key, private public key pairs, right? It's a private key, and private keys are supposed to be kept secret. So we hope that this private key stays secret and the bad guy actually can't get to the private key. The second one is a little more tricky. Next. So how do we prevent me from tricking some client into sending this header and make it look like they control this private key when they really don't? I just made them send this header. So one, because the client could just visit me, I download some JavaScript to the client, and then that launches an XHR, cross-origin XHR or something, right? So I can make the client issue HTTP requests. So one reason that can't be done, I can't trick the client into sending a header that makes it look like they're controlling the key when they really don't, is that the TLS unique isn't really known to me, right? It's the client has a connection to some other server. I control the JavaScript that is now running on the client and is doing this cross-origin call. I don't really know what the TLS unique is that is supposed to be signed. The second countermeasure, though, but I guess I want to say that the TLS unique isn't really treated the same way like a private key is or so, right? It is true that in practice, I don't really know how I would get hold of a TLS unique, but it's not something that we treat like a secret. So the other countermeasure, defense in depth, is that we don't let attackers set that token binding header. Next. And that is where that prefix comes in. So that was the reason I have this prefix there. And I think, Martin, you were the one arguing against it.
I'm the one saying this is not a good. Well, okay. Martin Thompson, this sounds like great rationale. We can wind back a little bit for me, please? So, and again, to the previous slide. Okay. So what you're looking at here is a situation where it's not the client that you care about. Because in all of these contexts, when someone is making the request, the person that you care, your real client involved in this situation is the one that controls the private key. What you're really looking for here is you're looking to avoid the by proxy HTTP requests that sort of can happen in the web context, where I operate a site and I can make you make requests against any other site. Basically, it looks like it's you, but it's not really, because I'm the one actually pulling the strings. And so it's this by proxy request that you're looking to sort of deal with here. Because obviously, if I'm the site and I control the private key and I'm the one producing these signatures, then you're really talking to me. And if you look through the way that this works, cause and the same origin model are all structured in a way that when I make a request via using your browser, I get information that only get information if the server that I'm making the request to specifically allows that to happen, or it falls into one of those odd exception loopholes that we put in for legacy reasons. So if we think about this a little bit more, and now I'd like to go on to the next slide because I think this is natural progression here. The situation where the attacker uses the victim's private key, we can't really do anything about that one. If your private key is stolen and you have that level of control over the private key, then too bad.
Right,
I mean,
right.
they can fire up curl and
Right.
Run OpenSSL and do a bunch of other things, and you're lost at that point. The other situation is rather more interesting. And this is the one where I set up some sort of authentication on a site using you as the victim. And I get you to log into Facebook, for instance, and I get Facebook to bind all of those lovely credentials down to my key. Now, let's think about what it means to actually do that. So what's Facebook going to do? They're going to send you a cookie, right? Can I see that cookie?
Well, yeah.
Actually, I now have to steal that cookie as well, right?
No, it's your cookie, right? It's your cookie, it's your key, and you're going to make me send that cookie and that key to Facebook.
How do I get the cookie? How do I set the cookie?
Right. So
I need to make you I need to force you into a situation where you use my private key with the browser. You log in and provide some additional information to the site that I'm looking to attack. And I need you to start accumulating additional state against this private key somehow, so that I can later go off and use that. How do I take advantage of any of that when I can't access the cookies, I can't set the cookies for some other origin? The web sandbox prevents all of this.
Right. So you can't set the I guess you're making my point, right? For the same reason that you're not allowed to set the cookie, you shouldn't be allowed to set this header either.
No, I think you're missing my point.
Okay.
There's no exploit here that I can conceive of. Now, I will ultimately concede on the point. Let's just make this clear. I don't mind you putting the sec prefix there. I have an aesthetic reaction to that I can get over. But we need to be very clear about this. There's nothing you can do here in this situation, unless several other things have failed in the process. You have to be able to
I agree.
Acquire people's cookies from other origins.
You have to be able to set your cookie on there. You have to be able to.
What value is that? If it's my cookie,
Yeah.
it's my state that I've associated with that cookie.
Yeah.
So that's of no value to me because it's my state that I'm able to exercise, and I could do that anyway without any of this.
the surveillance attack.
The
Right.
surveillance attack?
Yeah. So you make me use your cookie. So when you log into the account, you can see what I've been up to while I was using your cookie.
Okay, that's interesting. I don't know how you do that. I don't know how to set cookies on other origins.
Right. So I agree with you that several other things also would have to happen, right? I would have to know the TLS unique. I would have to be able to use to set the cookie.
Right.
And I would have to be able to set this header.
Or you would have to be able to build up all of this state and then somehow steal it back again. So I implant a whole lot of state on your machine based on your logins and your credentials, and I can steal your account because I now have access to this private key. And this only happens, by the way, on browsers that don't understand this this new mechanism, because when we boil this right down, the browsers that support this new mechanism will suppress all of this stuff. We will treat this new header field as being equivalent to a cookie or equivalent
Right.
to any of these other sorts of other things.
Right.
So again, we've narrowed the scope of applicability even further. So I just wanted to get this out there that you're drawing a pretty long bow on the attack here, and I'm trying to think whether there is actually an attack, and I've thought it through. I can't really think of anything. I'll let someone else talk now.
John Bradley, individual. I'm also perhaps not entirely understanding your attack, but that wouldn't be the first time. Isn't when this header is presented to the server, isn't the server actually verifying that the TLS unique and the key actually relate to that channel? So how, if the attacker has modified the header, it's not going to validate. So I think I'm missing something.
Right.
Well, yeah, but it doesn't have you got the wrong key.
No, so okay. So I'm the attacker. You're the victim client. Okay. You're the victim client,
Mhm.
and there's some server you want to connect to.
Right.
Martin is the server. All right. So somehow, I can't tell you how I would do that. Somehow I figure out what the TLS unique is between you and Martin. Okay. Then I have a private key here that I control that you have never seen before. And when you visit me, I send you JavaScript that sends a HTTP request to Martin. And if I can, in addition to knowing what the TLS unique is, also specify this header, I can now craft a header that will make it look to Martin like you control this private key, which you don't. I do.
It doesn't. So this only applies to the case where we're doing the federated. So the second assertion can be faked, not the first assertion. So there's an assertion with my key. I have a TLS connection
Right.
to the we'll use the RP client IDP terminology. So if I have a TLS connection to that IDP, there is a TLS unique. Somebody could have stolen it. We're still making the assumption that they haven't stolen my private key for that particular connection. All they can do is fake that they're a relying party that's on the second assertion to that IDP. They can fake that one. They can't fake the first one because they don't know my private key, and that's validated at the TLS layer.
If I can override this header, then you will never ever talk about your private key, right? When you send this request, you'll be talking about my private key. Yeah, exactly. You're an old browser who doesn't speak this protocol at all.
Okay, so this is an attack against Well,
okay. No, you negotiated the negotiations.
Well, yeah. How can I not support it while I support it? That's the part I'm not.
Yeah, I guess you negotiated. So I guess you do support it, but I overwrite the header.
Right, but then if you overwrite the header, it's going to be invalid because you don't know what my key is.
What?
Yeah.
We're not going to let that happen.
Well, so Either way, like
I mean,
if we
even
say
if
like
you
it
did
doesn't have
overwrite it, it would be invalid because you don't know what my private key is for that connection.
I override it. Your private key never shows up in this connection. It'll look to the receiving server like you're using this you're exercising this private key, but you're not, right?
Well,
Because
but-
I got to set the header.
Right, but it has to validate that connection against the private key that's actually on the connection. Otherwise, we have a failure.
No. If I can sign the TLS unique between you and the server, it'll validate.
Okay. So it will validate based on the header without reference to the actual underlying TLS keys and TLS unique, or
No, so
just
again,
on the TLS unique.
One on the TLS unique, right? One assumption I'm making, which I can't tell you how I would do it in practice, but one assumption that I'm making is that I know the TLS unique between you, the victim, and the server.
Then
And when I do that, I can craft a valid token binding message header with a key of my choice that you don't control.
then my suspicion is, my initial reaction to that is that we have a layer mismatch, and so
yeah, I mean,
let's
at the very least, right, we would have to say something like, you can set the header, let's say we don't have this prefix, the SEC prefix, right, which means you can set the header, but if the user agent speaks the protocol, it ignores it and uses the header it would have sent anyway or something.
My gut reaction is that the entity receiving it, the server, needs to check that the public key being used in both places actually matches on top of the TLS unique. But
okay,
let me try to answer. I don't know if I'll do any better. But so on the provided token binding, I don't think that this attack works. So the provided token binding is the browser actually talking to the server. That's the initial connection. That that binding will be pretty secure. I think that any cookie that the IDP provides to the client, so that the client presents it back to the IDP, that cookie is well protected. Now, once we have federation, we have a fake RP in this case, right? We have a fake RP that knows the TLS unique somehow of the client. The fake RP builds a header that looks valid, that proves possession of a key controlled by the fake RP, right? So that header goes to the IDP, is redirected to the IDP. The IDP binds a cookie of that user to this key that the attacker controls. So now that cookie has been...
the token that gets redirected back, because binding a cookie to the referred key wouldn't make any sense.
The cookie has to be bound to the referred key so that the RP can actually validate it. The reason the cookie is bound to the RP's key is that the RP can then validate that signature.
Do you mean literally cookie, or do you mean
It would be an assertion, not
identity token?
And that would be a token which is being sent to another domain via a redirect, not same. It's not the same
Yes,
origin,
it's
going to a different origin.
Yes, it's a federation scenario, right? So that cookie being signed goes to the RP, right? And in this case, we have a fake RP, right, which got the user's cookie, and the RP owns the private key for that binding. So therefore, the cookie has been exported. That's the attack, pretty much.
So I got that. By my logic, since the attacker has to replace the entire header, and it doesn't know the private key of the legitimate non-referred one, the server will reject it because one of the two tokens, the not referred one, is invalid. And if it doesn't, then that seems like a problem to me.
Damn. I wasn't paying enough attention.
It's all up to you now.
So
Yeah.
So the header that you're postulating the bad guy is replacing contains both.
I don't think this is a federation problem. I think you can think about this problem purely in the provided token binding context.
But he just said that the server who receives it is going to actually check the public key and not just the signature on the header.
We haven't resolved that problem.
So
what does that mean? Checks the public key?
Well, the public key, on the TLS connection needs to be the same as the public key that signed the header, or the information in the header.
There's only one key, the key that signs the TLS unique.
Well, right, but it should be the same key in both places. If you don't actually make sure it's the same key in both places, then your attack becomes possible.
There's only one place. There's a server receives the header. There's one public key mentioned in the header, and there is a signature with a TLS unique.
Right, but there is also a TLS connection that uses that same public key, which is...
No, I don't know what that means. No. There's only the TLS unique. The TLS unique is the thing that represents the TLS connection and all the keys. And there's one key that signs that TLS unique. Am I saying this right?
Yes.
Okay. So Martin, I think your argument was twofold. One was that there really is no attack here, and the other one was, and putting the prefix there is actually bad. And
okay. So the attack is crazy hard. I cannot conceive of any way to exploit this one, even allowing for the possibility that you can do a number of things. You can learn the TLS unique. You can inject this header. You can somehow convince a client that understands token binding such that it negotiates it at the TLS level to actually not understand TLS token binding to the point that it allows the header through.
Right.
And then at some point in the future actually take advantage of having some information that's been then bound to this token that is not somehow hidden from you. I mean, if it's a cookie, you're not going to have access to that because it's a cookie that belongs to another origin. Too bad.
Right.
If it's if you actually wanted to log into the site, you're not going to be able to log into the site because you don't actually have any of the credentials the user has.
Right. But you were just saying as part of this that somehow the client, even though I forget exactly the words you used, but
my
even though it
assumption here
understands
is that we need to treat this exactly like an authorization header field for someone who understands it, and that I think is completely reasonable. We on a client that understands token bindings, we and is willing to generate token bindings, we need to treat it as something that's not has the same sort of properties you're looking for.
Yeah.
The question is whether a patsy, the client that doesn't understand this, the one that doesn't support token binding, can be sort of manipulated in some way into doing something that might be usable by the attacker. And I cannot conceive of anything.
Is that the
without even with 3 or 4 things failing, I can't conceive of anything that could actually be used here. Yeah.
Is that the pre-flight stuff? Is that where or we said you should treat it like an authorization header? Is that where the...
So CORS has a bunch of rules about what to do with certain header fields in different contexts. And authorization header fields are only provided in certain narrow cases. And those narrow cases include where the server's okay with them and when certain information is not being made available back to the origin that initiated the request. So if I go to example.com, and some attacker wants me to make a request against example.com with my credentials, by default they don't get to see the response. Now, if they want to actually make a cross-origin request to example.com, I remove cookies, I remove the authorization header fields, I remove all of that sort of other stuff, and then the request goes through as if they may as well have been making it themselves directly. It's not really all that much use to them.
And why do you remove the cookies? Because the cookie...
I remove the cookies because cookies contain state that the server uses to identify the user, right, and might be used in the process of authorizing a given request.
And the way I understand Anna's request was that in the new fetch proposal, we're going to clearly mark all the headers that should be treated as such with an SEC prefix.
This is a CORS thing that I disagree with.
Okay.
But the idea is that CORS partitions off a space of the header field namespace and says anything starting with sec hyphen is special for cause, and we will not allow applications running in the browser to do anything to those header fields. And they've used that for WebSockets and a bunch of other things, all to no actual effect.
But do you agree that there are headers that are special?
Yeah, the ones that I just talked about, the ones that the browser knows contains information, and the ones that the sites know contain information that's relevant to this.
And then do you agree that this header should be one of those headers?
When we get to the point of adding it, yes, it should be. But
I don't really, okay, great, I agree. Great, so we agree. I don't really care whether we mark the header.
It doesn't actually help, by the way. It doesn't actually help in any material way, but I have no problem with making it one of those.
Okay.
So
I don't really care whether we
let me qualify that somewhat. There are no attacks based on being able to set this header field, not without some huge number of things to also fail, such that to the point that you actually fully control the client rather than just can I ask it to make a few requests for you.
Mm-hmm.
So at that point, there's no, but I would be willing to concede that you put it in the list once it's there.
Okay.
But it's not actually providing. It's a nice security blanket. You know, you can.
Right. No, I totally agree. It's a defense in depth. If you go forward
I'm not even talking defense in depth. I'm not even convinced it's worth that much.
If you forward 2 slides, right, you do, like, as long as you don't know the TLS unique, it's okay to set the header. It's just an additional
thing.
You
can set the header. I mean, even if you did know the TLS unique, it's okay to set the header.
If I did know the TLS unique? No, I see. So there I feel like we're getting into real possible attacks at this point.
I'd like to see something more concrete than that. That's my problem.
Concrete than?
What information can the attacker use in that context?
Right. So the attacker plants the credential on the client, right? And then makes use of the fact that somebody else is using the same credential as the attacker, the surveillance attack. Like,
so there,
like we have
not John again. So they're not specific to this, but there have been cases of attacks where the user is confused is forced through whatever means to log into an account controlled by the attacker, which then allows the attacker to harvest some other information from the user's activity, which is then used to later attack the user in some other way. But there are theoretical attacks where getting the user to log into an account that the attacker controls when they think that they're logging in someplace else could lead to disclosure of information inappropriately. It's like
I'm seeing a lot of hand waving right there.
No, okay. So we actually go through some pains to make sure that you can't, for the login page, Google login page, you can't send me a username password and then just post the form, like that would be what we call a login XSRF, right? It's like an XSRF but for login. That we consider that an attack because you get to pick which account I log in, and then you can have a look at that account and see what I was up to while I was logged into that account.
I don't want to stop. We got about 10 minutes, 12 minutes left on the agenda slot, right?
Okay.
So, no, this is clearly important stuff, right? But it would be really even better if we could actually write this down somewhere. Right? I mean, it sounds like we're missing a threat analysis. Yeah. I don't want to fall into the usual IETF trap of requirements draft, use case draft, and threat analysis draft. But can we just have a section in this draft that goes through some of the threats that people can imagine, and even if it's just this threat is not valid, just explain why it isn't valid.
It can just be expanding the security consideration.
Yeah, just put some text in the security. Yeah, put some text in the security consideration section that lists, even if there is a couple of attacks people believe are valid but aren't really.
Right.
Just sort of tell us why they're not, right?
And okay, I'll do that. I just wanted to say that I'm not married to the SEC prefix. It sounds like You were saying you would be happy to treat this thing like a cookies header or cookie header or something. That's negotiated between. That would be fine with me as well.
So my understanding is that the sec prefix has been a little bit controversial in certain circles, right? So we might get pushback. We could just as well sort of punt on this issue a little bit until ISG review, because we might get slapped by this with this and sort of get to change it anyway. So let's not sort of spend.
All right.
It seems like we're rat holing a little.
Can I make the following proposal then? I will take the prefix off, but will explain in text that it's a special header that shouldn't be set, and explain in the security considerations why.
This comes back to what you want from fetch.
Yeah.
It's a question that we need to answer.
Yeah. All right. Okay.
Are we moving on, or? We're moving on from this?
I guess so.
Well,
You were in the line. Stop being shy. I know it's
I
your
don't want to
first.
perpetuate the rat hole, but
Say
I guess
your name.
William Dennis. I'm hearing a lot of arguments here that there's no benefit having that prefix, but I'm not actually hearing what the harm is of having the prefix. But I mean, I don't really want to rat hole anymore, so.
So just to make the point, right? Even if we keep the prefix, don't have the prefix, we could get pushback either way in our ISG and IETF review of this, right? So it doesn't really matter what you do at this point. Write down the text explaining why, right?
Okay.
And then we'll get to figure it out later.
Sounds good. Sounds good. All right. Last thing that came up on the list was a question. I think Brian or somebody asked, what do we do about other federation mechanisms that are being used? How do we support those? And so next, what I'm going to do is I'm going to walk through different ways how federation can be done on the web and how we do token binding there. So this is the general case. So at the very high level, federation always looks like this. Client goes to the relying party and says, I want to log in. Relying party says, go get an identity token from the IDP. Next. So then the client goes to the IDP and says, hey, I'm supposed to get an identity token from you. And then the IDP says, all right, here's your identity token for the relying party. And maybe there's a step in there where the IDP says, who the hell are you? And the client answers that question. But here's your identity token for the relying party. And then next, the client says, here's the identity token I got from the IDP. And then the relying party looks at the identity token and says, oh, great, you logged in. Here's your cookie. So they all fall into that general scheme, but exactly how you do step number 2 and number 3 and so forth varies. Next. Right. So, but of course, with token mining, what we would like to do is we would like this identity token that is being sent in step number 5 from client to relying party to be bound to that TLS connection, right? Next. So when the IDP issues the identity token in step number 4, it needs to be somewhere in the identity token. It needs to say, by the way, this token is bound to the following key, right? Okay, next. So with redirects, it looks something like this, right? When the step number 1, it says, hey, I want to log in. This is this HTTP request up there. And step number 2 that says, hey, go get an identity token from the IDP looks like this. It's a 302. It's a HTTP redirect. And the way we reveal to the IDP this public key that it needs to put into the identity token is by having this response header that says, when you go to the IDP, don't just reveal the key that you normally use with the IDP, also reveal to them the key that you normally use with me, the RP. Next. Next. So in that header, instead of having just one signature, we now have 2. We have also the signature that proves to the IDP that the client controls the key that it normally uses with the RP. And so now the IDP can craft a identity token that talks about that referred public key, and thus binding it to the connection between the client and the RP. Next. All right, but it doesn't always, a federation isn't always done that way. sometimes it's done something more like this. Instead of issuing a 302, the relying party actually responds with a 200 and a bunch of HTML. And somewhere in there, there's a form, and then there's a little bit of script that auto submits the form to the IDP. This happens usually when the data that needs to be transmitted between the RP and the IDP is too big to fit in the query parameters of a URL. So in the SAML world, you often see something like this, for example. So what happens when the client receives such a piece of HTML? Once this forms.submit thing runs, right, it will issue usually a post request to the IDP, and now the IDP has all the data it needs to know to issue the identity token. And usually in SAML land, you go back the same way. So the IDP also responds with a bunch of HTML and a little auto submitting form. Next. So the question here is the same question, right? We need the client to include a second token binding statement here, so that the IDP knows what to bind the token to. And the question is, how is this triggered? Right? In the document, we don't talk about that in the draft that I wrote. Next. Here's another possible thing. This is more of a, I'm not sure whether anyone's actually doing this. I'm not sure. But you could imagine doing it like this. So you use this newfangled fetch thing. So you respond with the 200 with some HTML or JavaScript, and you just say make a cross origin XHR. So when that script gets executed, next, you make a cross origin XHR, next, and next. And the question again is, well, how does it happen that when we make that particular XHR, that the second binding is also mentioned in the header? Next. Post messages.
So Martin Thompson, I just have to point out that's really very dangerous to do that, because the IDP has to set cause headers and only exfiltrate information that it absolutely is 100% confident about. You don't have any option to interact with the user, unlike the redirect case where you actually land the user on the IDP site and you can interact with them in whatever fashion you like. You've got that one shot, and that's it.
Yeah.
So,
right. I would imagine that you would use this to shortcut the case where the user's already logged in at the IDP. And
right. So you would make a sort of test query, and if that one failed, you would fall back to a redirect.
To some of the others.
But yeah, I just have to point out that getting the cause right in that context is tricky.
Okay. All right. So here's I think the last sort of mechanism. This one I have come across. Both Google and Facebook use mechanisms like that, where what happens is the RP again responds with a bunch of HTML, but part of the HTML is actually an iframe that points to the IDP, and then they post message into that iframe and say, hey, I want to get the token. And then there's JavaScript sitting that was served by the IDP, sitting there waiting for that post message, for that event object basically to be thrown into the iframe. And when that arrives, it then makes a first party call, not a cross origin call. So next. So you see that I put an origin in here. So you see that because the iframe was notified, then some JavaScript inside the iframe said, okay, now I'm going to turn around. I'm going to ask for the for the token. And the same question, next, the next, how in this case would we make it so that that the IDP knows what to bind the token to?
We cannot allow this to happen, unfortunately.
Well,
because this basically allows me to query for the tokens that you're using across any site.
I'm not proposing any particular thing here.
If the one before was dangerous because you might screw something up at the server, this one is an attack. So
which part is the
Because there is no information in this context available to the browser to determine that this request was actually originated at rp.com.
Right.
So at some level, the IDP code running in the IDP worker or whatever it happens to be in has to say, please give me the access to the token for rp.com. And we just have to take them on faith if we're going to be able to do this, because we have no other information available to us.
Not necessarily, but I'm not actually proposing that.
Excellent.
Good. All right, next. See the 3 question marks down there? I'm not proposing anything for this thing. So how do you trigger the refer token miners in these different cases? So for the redirect-based case, I had actually spelled it out on the slides, right? And it's also in the draft that is submitted. There, it's a response header that the RP issues in the as part of the 302 response, and you could imagine DOM APIs or I guess JavaScript APIs for the other cases. For the post-based form, you could imagine that maybe when you have a form, you have an extra attribute there. When you do fetch, you have an extra parameter there that you put there. For post message, I have some ideas, but I wasn't even going to talk about them. So I'm just going to put 3 question marks there. But the point I'm really trying to make here, next, is that for this draft that sort of looks at the HTTP level, we should really only worry about the first part and have the other things be discussed somewhere else. So for example, for the fetch based things, I've started talking with is it WG or something who looks at the fetch. Not much has happened there. But the point, and maybe this is sort of where I'd like to get some consensus, is that these conversations happen somewhere else, and we're going to worry about just the first piece here. Next. So those are the 2 things that were open. Sec token mining versus token mining. I think we came to a conclusion there, what to do. And the second open thing is like the extent to which you're going to spell out federation support in the spec. And my proposal would be to only include the redirect-based case.
So Martin Thompson, I think that the point that John raised earlier really needs to be addressed before we can get to the bottom of this federation thing. Because I think if we come to a place where we're happy that the IDP can simply use a public key without any proof that the client uses that actually is in control of the corresponding private key, none of these mechanisms are actually required. And that would be a happy place for me, because it means that I worry less about this correlation linkability problem that we're talking about, and a very happy place because I don't have to worry about new HTTP headers or new arguments to fetch or new HTML form attributes, which all of which scare me, and it means that you can actually solve the post message problem because that information is available to your origin.
Right. So here's actually why in the post message case there would be an actual attack. So let's take John's argument a little further than I think he actually meant to take it. But I'm gonna just as a thought experiment, all right? I'm gonna take it to its extreme, right? So if the IDP doesn't verify the referred token binding, what's the point in actually providing a signature? You might just mention the public key instead of making it sign anything, right? There's no difference. So if we just mention the public key, what's the point in putting it in that special header, which is, I think, Martin, what you were just saying, right? The RP knows what the public key is. It could just stick it in a URL query parameter or something, right? At this point, we're sort of functionally equivalent. So
you're correct in this hypothetical road, which
right.
wasn't the one that I was on, but there would be no point in actually oversigning the key at that point.
Right.
You could just send it in the message.
So now, if the key is just sent just the public key is just mentioned as a query parameter, right? Now we have an attack. We have a man in the middle between the client and the relying party who gets to change that public key.
In principle, the many protocols, SAML OpenID Connect support signed requests, so it's possible that you could put the key in a signed request so that they couldn't tamper with it. I'm not saying that's a good idea, that solves all the problems, but that is one way of dealing with it. In principle, most don't sign the request, but most also don't do proof of possession either. So it's new ground either way.
Yeah. Right. So we had an earlier version. Andrew, you might still know about this. An earlier version of this where instead of proving possession of two keys by both signing the TLS unique, I had these keys countersign each other and actually have that pop up into the JavaScript and so forth. And there you could prove that if only one key signs the other or only the other key signs the one key, you open yourself up to attacks. You really need the mutual certification of the keys basically, or alternatively, you need to prove possession of both of them.
Folks.
Right. So
just to note that we are actually 10 minutes over time already.
So I'll be quick. John Bradley, yes. So I think we have a good handle on the redirect. We have to look at 302 redirect. We have to look at these other mechanisms and make sure that the security is actually appropriate. The ones that we're punting on, we do still have to see if there are additional security considerations that apply to them besides just letting somebody deal with the syntax. My question is on things like native applications which aren't necessarily using a browser user agent. Are we likely to say anything about, well, how does an OAuth client on a native device do this because it's not actually a user agent? There is another class of applications out there that may want some thinking about how do you do this. Since you're not having a browser actually send this header, how do you get the key information from point A to point B and do the cross-signing or whatever it is we're doing? Or we could say you can't do it cross-origin in native apps. We probably need to either figure out something to say about it or say just don't do it.
So we definitely need to work more on the security consideration section there and actually have that threat analysis. And I think at this point we need to continue this discussion on the list and let
I
people.
can write up an argument just for the list.
Yeah.
Why we can't just mention the key.
Right. Right. I mean why not put that in the security consideration section? I mean, people are going to review this that have no background, right? So you know.
Okay.
It doesn't hurt to actually have it in the ID. All right, we're done. Thank you very much. And if anybody didn't sign the blue sheet, come up and do so. Thank you.
It's like the week before IETF.
I mean, we're essentially a real disparaging. People do have it. People can do. There's a real disparaging. Yeah. So we could do something else.
Yeah. Right. No, I don't know that there's. I guess the other possibility, some people might be going to the